Okay, now let's take a look at the explicit relevant feedback. In a classic relevant feedback cycle, normally a list of the retrieved document is presented to the user. It's around 10 or 20 documents. And then the user will examine them and then marks those that are relevant to them. And the main idea is to select important terms from the document that have been identified as relevant and then use that information in order to enhance the importance of this term in a new query formulation or the new modified query. So we select what is the important terms in the document, and then we use that term in order to enhance the query. By doing that, we are enhancing the importance of this term in the new query. So it is expected that by doing that, the new query will move towards the relevant document and away from the non-relevant one. So for example, Rocchio method is designed to reformulate the query in such a way that it moves closer to the relevant document and away from the non-relevant document. So in the early experiment, they have shown good improvement in terms of precision for small text collection. And the relevant feedback basically present the following characteristics. It hides the user from the detail of the query reformulation process, and it breaks down the whole searching process into a sequence of small steps that can be understood easier. So in the Rocchio method, so if two documents are similar, they will have similar characteristics. So document identified as relevant to a given query, they will have similarities among themselves. And for non-relevant document, they will have term weight vector which are dissimilar from the relevant document. So using Rocchio method, the whole idea is to reformulate the query such that it gets closer to the neighborhood of the relevant document in the vector space and away from the neighborhood of the non-relevant document. For instance, let's suppose we have the initial query here, and then we know that this is the known non-relevant document, and we have a small bunch of known relevant document here. So we want to move from this side to the other side that is closer to the relevant document that we have here. So this is what we call revised query or modified query. Let us define terminology regarding the process of a given query. So let's suppose we have CR, set of relevant document, among the document retrieved, and the size will be NR. This is basically the magnitude of the relevant document, the number of document. And then we also have set of non-relevant document, and the size of this will be N and R. So together this relevant and non-relevant document, we will have the total retrieved document that we have. And of course, we have some other relevant document which are not retrieved. So we will have a set of all relevant document, and let's N be the number of document in the whole collection. So we will use this symbol later on in the Rocchio method. So let's suppose we know what are the relevant documents in advance. Then the best query vector for distinguishing the relevant from the non-relevant document is given by this formula. So in which we have two parts. So the first part is the relevant document. This is for all vector of document that belong to relevant document. And then we subtract from the all document which are not belong to the relevant document. So what we want to do here is that we want to optimize our query so that it's closer to the relevant document but away from the non-relevant document. So that's why we minus here. And this is the symbol that we have. So this is the magnitude of the set CR, the size. So basically we are taking the average of the all the weights that we sum together. However, in a real world situation, we do have Q, the query, and also the relevant document is not known a priori. So to solve this problem, we can formulate an initial query and then to incrementally change the initial query vector. So for instance, let's consider the first part here. So this is for the when we know what are the relevant documents. So in order to get the optimized query, we take the relevant document minus the non-relevant document. Then we get the optimized query here. But if we have our initial query here, given a query Q, then we will start having this query Q. So we need to add a vector of set of relevant document and then minus set of non-relevant document. Then we can get the modified query. So we have two formula here. So this is when we do not have any query, and this is when we have a query. So basically we have three scalar here, the alpha, beta, and this one. So basically the first part is the relevant document. Okay, the second part here will be the non-relevant document. So what we want to do is modify this query to become QM by moving towards the relevant document but away from the non-relevant document. So basically the reasonable values of the parameter are given here. This is based on research. So the alpha is 1 and then 0.75 and then 0.15. So we will look into one example on how this Rocchio method can be used to modify query. Okay, let's suppose we are given a TF-IDF term document matrix, and the red one are non-relevant document, and the blue one are relevant document. So our query will be 10.71, 1, and 00. So all these are the weightage with respect to all these terms that we have. So we have Chinese, Japan, Tokyo, Macau, Beijing, and Shanghai. So if we consider the first part here, we will basically add up all these non-relevant documents and then find the average, and we add up all these relevant documents and then we find the average here. So basically for the modified query, we take the initial Q and then we add with the vector of relevant document and subtract the vector of non-relevant document. So when we simplify them, we finally get this modified query. So these are the weightage that we will key in, or this is the weightage that will be used as to represent the vector of modified query. So for your exercise, given this Q and also all these non-relevant document and also relevant document, you are requested to compute what is the modified query. So you need to pass up your answer.